Hey guys, it's Mrs. Carney. It's actually Monday, April 13th, so you might hear the wind howling in the background, hoping nothing crazy happens or gets blown over, but we'll just see how it goes. So this is part 2 of the 9.4 notes. And so in this part, we're going to really be talking about solving our initial steps into solving polynomial equations and how factoring using the GCF is going to help us do that. So there's really three main things that we're going to do today. The first one is we're going to learn about the zero product property. Then we're going to talk about what roots are. Actually, we're going to do that in the opposite order. And then we're going to solve polynomial equations by factoring using the greatest common factor. So the part 1 of your notes was learning how to factor using the greatest common factor that Mrs. Dubois did. And so you're going to see that make an appearance today. So the first thing I want to point out to you is if you just kind of go back for a second in your math career to either last year or maybe early this year, and let's say you are being asked to solve this equation, then what you're looking for when you hear solve from your teacher or the directions is you're looking for the number that when you insert it here and multiply by 3 and add 1 is going to get you 10. Now, with a quadratic equation or a polynomial equation, the solutions are actually a little bit different. And if you remember from some of the investigations that we've been doing, we've been focusing a lot on x-intercepts. And so if you picture that on a graph, so over here I just kind of drew a random polynomial or parabola. That would be a quadratic equation. And so we've been focusing on these points, our x-intercepts. And so what's actually special about x-intercepts, no matter where they are along the x-axis, whether it's a quadratic or linear or cubic, whatever your function type is, an x-intercept always has a 0 for your second coordinate. So like that first one is 1, 0, and the second one is 4, 0. So since we're going to be focusing on x-intercepts, and x-intercepts always occur when y is 0, that's actually what our solution to a polynomial equation is going to be. And a synonym for solution, the more common word that you hear a lot is roots. And so roots are going to be the values of x that make a polynomial equation equal 0. And so this is going to be a big thing, having it equal 0. And so a synonym, you might also hear zeros, and then they're also the x-intercept when graphed. So if I come back to my little picture that I made over here, I've got this quadratic equation that actually has two solutions. It has a solution here at 1, 0, and it has a solution here at 4, 0. And so you can see clearly that they're the x-intercepts because they're hitting the x-axis, but also you might hear them just called the zeros. And so 1 and 4 would be your zeros of the function. So just kind of interchangeable language there. And if you go back just super quickly to remember the degree is telling you the maximum possible roots that you could have. So again, not that we're going to see that a lot right now, but just kind of moving forward, if you had a 5th degree, that would mean you could have up to 5, or if you have a 2nd degree, a quadratic, you could potentially have up to 2 roots. And so you'll hear me use the word roots interchangeable with solution a lot throughout this. So now we're going to talk about the zero product property. And so what the zero product property says is, let's think about this little scenario first. So let's say I had A times B times C and it equaled 0. Then what must be true? I want you to think about that for a second. And so I'm also going to use color to kind of help me, because I'll bring that back down when we get down here in a few minutes. So let's say we're multiplying the green A by the red B by the red C. We don't know anything about them other than they're being multiplied, but we also know that the answer is 0. Then logically what we could figure out is that, well, one of these three things has to be 0. And the reason for that is it doesn't matter how many things you're multiplying. If you're multiplying if you're multiplying by 0, you're always going to get an answer of 0. So if our answer is 0 over here, that must mean that one of these three things is going to be 0. And in this case, it's pretty simple. That either means that either A equals 0, or B equals 0, or C equals 0. What we're going to do with this is we're just going to extend this concept just a little bit, and instead of it being A, B, and C just variables, these quantities are going to become polynomials. And so they might be binomials or they might be monomials. Okay, so here I am multiplying. I happen to be multiplying three things, and I get an answer of 0. In this example, I'm also multiplying. My multiplication is happening right here at the back-to-back parentheses. So I am multiplying, and I'm multiplying two quantities. But again, instead of it just being an A and a B, here's quantity 1, that's my red quantity, and here's quantity 2, that's my green quantity. And my answer, I can see, is 0. So if I'm multiplying red by green and getting an answer of 0, that must mean that either my red quantity equals 0, which is x plus 2, or that my green quantity equals 0, which is x plus 4. And so now I have two simple equations, and I'm going to solve those the way that I always would have. So in the red one, I would subtract 2 from both sides, and so x would equal negative 2. And in the green one, I would subtract 4 from both sides, and x would equal negative 4. So my two roots, or my two solutions, are going to be negative 2 and negative 4. And I could actually prove that this would work by going back to this and seeing what would happen if I were to plug in these numbers each one at a time. And so if I had x plus 2 times x plus 4, and I replaced x with negative 2, let's just start with the red one. Everywhere I see an x, I'm going to put a negative 2. Well, negative 2 plus 2 is 0, negative 2 plus 4 is 2, and that would multiply to get 0, so I'd get the right answer. Or I could do it again, and this time I could try it with my second root or solution, which is negative 4. So everywhere I see an x this time, I'm replacing it with negative 4. And, oops, I messed that one up. Sorry about that. That was supposed to be a 2. And so then I've got negative 4 plus 2 is negative 2, negative 4 plus 4 is 0, and then negative 2 times 0 would, of course, be 0. So you can see that these two roots, both of them, if I were to replace x with those numbers separately, would produce an answer of 0. So there's 4 more examples on this page. Let's just try two of these together, or sorry, one of these together, and then I'll pause the video and let you try a few on your own. So in this case, again, I've got two quantities that are being multiplied. I've got my red quantity and my blue quantity. They're multiplying, and the answer is 0. And so what that tells me is that either my blue quantity, which is x minus 5, that's got to be the one that equals 0, or my red quantity, which is x minus 1, that's going to be the one that equals 0. And so in this one, if I add 5 to both sides, I'm going to get x equals 5, and on this one, I would add 1 to both sides, so I'm going to get x equals 1. And I'm sure there's some of you out there saying, I can do this in my head, pretty straightforward. Absolutely. I would just hesitate, be careful when you get down to ones that are a little bit more complicated, and maybe actually showing out the work would be a little bit more helpful. So just be careful. Take shortcuts when you can, but don't take them when you can't, if that makes sense. All right, so what I'm going to ask you to do is to complete examples 3, 4, and 5. Pause the video, and then press play when you're ready to check your answers. Okay, so on example 3, again, I've got two binomials, red and green. My answer is 0, so I either know that x plus 3 equals 0 or x minus 5 equals 0. I saw both those equations, and so my two roots are negative 3 and 5. Same thing here, I've got two binomials. The difference is these aren't just one step, like here all I had to do is minus 3 or add 5 to get x by itself. On this red one, 2x plus 1 equals 0, I have to subtract 1 and divide by 2, and so that's going to get me a root of negative 1/2. And on this one, 3x minus 4, if that happens to be the part that equals 0, then I would add 4, divide by 3, and so my second root is going to be 4/3. Again, you still might be thinking, I can do this in my head. I promise it will get more complicated, so just have really good steps and focus. Just be careful, especially with your signs. This one's a little bit different because this time it's kind of back to like the ABC. I've got three quantities that are multiplying each other, each color-coded, and so if 4x is the one that happens to equal 0, that would mean I would divide both 4 on both sides to see what x would be. So that means if x were 0, then this whole product would equal 0. Or maybe it's the green quantity that equals 0, and so I would do 3x minus 2 equals 0, add 2 to both sides, divide by 3, and so another possible root is 2/3. Or maybe it's the blue quantity that equals 0, and so 5x plus 4 equals 0. I'm going to minus 4 from both sides, divide by 5, and so my third root is x equals negative 4/5. And so for right now, all of them are going to be our answers because there's no context. They all make sense. So now we're going to apply the zero product property, but we're also going to bring back the factoring using the GCF that happened the other day. So the first thing that I'm going to do is on the left side of my equal sign, I'm actually going to factor this as if it were an expression. So 2x squared plus 8x, I would find the GCF, which happens to be 2x. I would write the remaining binomial, which would be x plus 4. and then I'm going to just bring down my equal sign. And so right now, the first thing I would kind of do in my head is I would just check to make sure that does this match this? And so I would distribute it in my head and say, okay, 2x times x is 2x squared, 2x times 4 is 8x, so I know that this is the correct factored form of this binomial. The other thing to look out for to know that you factored completely is just look inside your parentheses and make sure there's no GCF left behind. Sometimes you think you took out the GCF, but then you'll see like these two things actually have something in common. So you just want to make sure you're taking out as much as you possibly can. And so now I've got my two quantities. So I've got my green quantity multiplying my red quantity, and the result is 0. And so that means I know that either my green quantity, which is 2x, has to be the one that equals 0, or that my red quantity, which is x plus 4, has to be the one that equals 0. And so this one I would divide both sides by 2, and so one root is going to be x equals 0, and the other one I would subtract 4, and so my second root is going to be negative 4. Let's try one more together, and then I'll have you pause and do some on your own. So let's do example 7. So again, the first thing I'm going to do on example 7 is I'm going to factor the left side. So I'm going to find the GCF of 3 and 18, which is 3. I'm going to find the GCF of x squared and x, which is x. I'm going to write what's left inside, which would be x plus 6, bring down my equal 0. And so now I've got my two quantities multiplying each other, the result of which is 0, which means either red or green must equal 0. And so if green equals 0, 3x equals 0, divide both sides by 3. That means one root is going to be x equals 0, or maybe it's the x plus 6 that equals 0, subtract 6 from both sides, x would equal negative 6, and so I've got two roots to this polynomial equation. So I'd like you to try examples 8, 9, 10, and 11. If you notice, 12 has an asterisk next to it. There's just an extra step there. So you can try 12 if you want, or when you're done with 8, 9, 10, and 11, you can press play to check your answers, and then I'm going to give you a little hint to try on 12. Oops, and I just noticed something as I started to do these. Examples 10 and 11 are actually missing the equals 0, so go ahead and add those, because if they weren't equations, they wouldn't be solvable. They would only be factorable. So just make sure they say equals 0. I'm actually going to probably edit this so that way yours will say it, but when I'm recording this video, I don't have that. So just note that yours probably say this, but mine don't by accident. Okay, pause and work. Okay, so on example 8, my GCF is going to be a, so it's going to factor into a times a plus 5 equals 0. So then either a equals 0, that probably seems silly, but it's just already solved, so kind of simple, or a plus 5 equals 0, which would mean a would equal negative 5. So my two roots in this one are 0 and negative 5. Factoring 3s squared minus 9s becomes 3s times s minus 3, and so then if 3s equals 0, s would equal 0, or if s minus 3 equals 0, s would equals 3. And again, along the way, you can check yourself by just making sure, okay, if I were to distribute this, would it give me that? And if it would, keep going. GCF of 6n squared and 15n is 3n, so that factors into 3n times 2n minus 5 equals 0. If this quantity were to be the one that equals 0, n equals 0, or n equals 5 halves. And then the GCF of 4x squared minus 2x would be 2x, and then 2x minus 1. Remember, this is getting divided by that, because when you're distributing, you're multiplying, but when you're factoring, you're dividing. And so 2x divided by 2x is our 1. And so then if 2x equals 0, x would equal 0, or if 2x minus 1 would equal 0, x would equal 1/2, because I would add 1 divided by 2. And so if you want to take a look at 12, if you look at 12, it has a little difference in it compared to 8, 9, 10, and 11. So if you look at 8, 9, 10, and 11, all of those examples started by equaling 0, and this one doesn't. But since solving, that's the directions are to solve. Remember, the solving meant to find the value of x, or in this case, the variable happens to be s, that's going to make the polynomial equation equal 0. So the very first thing that I need to do is I need to rewrite this so it equals 0. And the way that I would do that is I would subtract 14s from both sides. And now if you're wondering, well, could you also subtract 4s squared from both sides? Absolutely, you could. But generally speaking, if possible, we want to go in descending order, and if we can get this leading coefficient to be positive, then we would do that. So if I were to do it the other way, if I had subtracted 4s squared, it would have looked like this. It would have said 14s minus 4s squared. But then I might flip the order around to make it go from highest to lowest exponent. And so now you can see the subtle difference of this is negative and this is positive, but over here the 4s is positive and it's negative. Mathematicians just think this looks a little bit nicer. It's the first thing that you're looking at is positive instead of negative. So it's like, you know, you don't want the first thing that you see to be negative. But if you did it this way, you would get the correct answer. And so now that I have this in descending order and equaling 0, that's the most important thing, it equals 0, I'm going to take out the GCF, which would be 2s. And so then I'd be left with 2s minus 7. And so then my first quantity could equal 0, which would divide both sides by 2, I'd get s equals 0. Or if 2s minus 7 equals 0, I would add 7, divide by 2, and so I'd get 7/2. And it's also customary when you have fraction answers, and you can see it back up in this one, to leave them as improper fractions. Not that you can't change them to mixed numbers, but it's just more common to see them written as improper fractions. It would be especially helpful if you wanted to take, say on this one, 5/2 and go back and check that it actually produced an answer of 0. To multiply fractions, they need to be improper anyway, so you're kind of saving yourself a step. So our last goal for today is to apply this idea of the zero product property and factoring using the GCF to area word problems. There's also going to be another type of word problem that we're going to focus on Thursday and Friday, and those are vertical motion. But for right now, we're focusing on area because you're doing like length times width, that is going to produce often a quadratic equation. And so then we can solve them using factoring. So in this first example, it shows two rectangular rooms that have different dimensions but the same area. And so I've got this rectangle has a w plus 2 by w, and this rectangle has a 2w by a w minus 1. And so again, I'm just going to use color to help me kind of identify my two rooms. So I'm going to call that my red room, and I call this my green room. I happen to be sitting in a blue room, but you can't see me. So to find the area of the green room, I would do length times width, and so my length and my width are w and w plus 2. And then to find the area of my red room, I would do the same thing. I would do its length times its width, and so 2w times w minus 1. So I've got my area, and it said that. But it also tells me that their areas are the same. And so what that means is that the green area is going to equal the red area. And so I've got green equaling red, I've got my area expressions. And so now I'm going to start to simplify. And so on the left-hand side, I can distribute w squared plus 2w. And you're probably thinking that your gut was telling you to do that anyway, and so you're right on. And over here, I'm going to distribute and get this. Now I want to solve this. I actually want to figure out what w equals. But remember, just like on example 12, we're not ready to solve until I have this equaling 0. And so I can do two things to make this equal 0. I can take my green stuff and bring it over to this side of the equation, or I can take my red stuff and bring it over to this side of the equation. It really won't matter which one you choose, but we're going to do the one that kind of looks the cleanest. And so if I were to bring over red, which might be your first gut instinct, bring everything over to the left, you would have to subtract 2w squared from both sides, and it would get subtracted from its like term. And so w minus 2w squared would be negative. And when I'm in descending order, I don't want that first thing to be negative. So I'm actually going to take my green stuff and subtract it over, which means I'm going to subtract w squared from both sides. And you could do this in two different steps if you wanted to. But I also need to subtract 2w from both sides. So I'm going to draw a line. Now it equals 0. 2w squared minus w squared is going to be 1w squared. You can either write the 1 or you don't have to. And the key here is that this is really negative 2w minus 2w, which is going to be negative 4w. And if you wanted to write it w squared minus 4w equals 0, that'd be totally fine. And so now that it equals 0, I'm ready to factor. So I'm going to find the GCF of w and 4w, w squared and 4w, which is just w. And so then that factors into 0 equals w times w minus 4. And so now I've got my two quantities, red and green. And so I'm going to solve those. And so that means that my two roots are, it's a highlighter, w equals 0 and w equals 4. If I go back to the picture though, and if I look at just say start with the green rectangle. Well, if this was 0, I wouldn't have a rectangle at all, I'd have a line. And if this was 0, same thing, 2 times 0 would be 0. So even though this quadratic equation right here, if I were to graph this, it would have 2 roots. It would cross the x-axis twice. It would cross at 0 and it would cross at 4. Within the context of this problem, they both don't make sense. Only one of them makes sense, and the only one that makes sense is w equals 4. So sometimes we can have multiple answers, and sometimes only we have to eliminate some based on context. So at this point, I'm going to pause the video. I'm going to have you try the next problem. It's very similar. It's still dealing with area and the fact that their areas are the same. You're going to need to know the dimensions of both of your rectangles. Press play when you're ready to check your answer. Okay, so on this one, I've got my taller rectangle that I'm kind of using red for, and I've got my sideways rectangle that I'm using blue for. And so to find the area, I need to know length times width. And so the width, width, W, is W. And then the length of this whole thing is 3 plus W. So that's where that came from. And then I distributed that through. And then this rectangle has W by, if this whole thing is 7, but this is W, then this piece remaining would be 7 minus W. And so W times 7 minus W. And it told us back here that they had the same area. So my red area is going to equal my blue area. And so that's my simplified equation. If you were to leave it like this, it's not that you're doing it wrong, but you just didn't simplify it. So that's my simplified equation. Or maybe you took it even a step further, which is you got it equal to 0, which is actually what we're going to start doing now. So I just rewrote this equation here. I had 2 choices. I could slingshot my 3w and my w squared over, but I'm choosing to go this way because I want this one to be positive. If I were to subtract, it would have been negative 2w squared. So I added 7w and subtracted 7w. This is me showing you I'm doing it on both sides of my equation. The other thing I did just at the same time is I reordered it. So w squared plus w squared would be 2w squared. I'm going to do that first, and then 3w minus 7w is minus 4w. Then I factored using the GCF, so 2w times w minus 2, which gave me 2 roots, 0 and 2. But again, I can't have a rectangle that has 0 for dimension. So even though this quadratic equation has 2 roots, 0 and 2, if I were to graph it, I would see it cross the x-axis twice. Only one of them is reasonable and makes sense within the context of the problem. So width has to be 2. And so then it asks for the total area of the desktop. So I need to know this area and this area. And so I just drew little sketches down here. So this would be a 5 by 2. So that area is 10. You could just double it at that point because you know they have the same area, so they're both going to be 10. I just checked it on my blue one as well to make sure, well, wait a minute, if this is 2, does it actually give me the same area? And it does because it's going to be a 2 by 5. So your total area is 20 square units. Thanks for listening.